I have for you today another comfy ride-along Threadripper Pro build. Yes, you can build a Threadripper Pro workstation. It's a little more complicated than building a computer. If it's been a while since you've been, built a computer, they're complicated, expensive beasts, and it can be a little intimidating. We're going to be building a Threadripper Pro machine based around our WRX90 WS Evo from ASRock, and I want something I can meaningfully use our RTX Pro 6000 96 gig GPUs. This is an $8,500 GPU. We also have the 32 gig Radeon AI Pro 9700, R9700, 32 gig. This is a 9070 XT, but with 32 gigs of VRAM, basically. And this is also for AI things that need 32 gigs of VRAM, which I could buy like, I don't know, 5 or 6 of these for the cost of one of those, which is fun and interesting. I need a lot of Threadripper machines around the office here at Level 1 Techs because I've been doing a lot with AI and I've been taking up a lot of space and I've been chewing up every byte of flash memory that we have, and I've been working on, building like Strix Halo clusters of things, which is run into a little bit of a networking issue on that side. But we're going to build a workstation out of a WRX90 WS, and that's really most of the point of this video, but this is also, understand, part of a larger thing that I'm doing. We're going to also build a Threadripper non-pro workstation. Look for that video. It may already be out, or it will be out soon. It may already be up on Patreon or Flowplane, but I'm rambling long enough. Let's get started with the build. Let's take a look at this and do all that. Now, this is kind of a second generation WRX90 motherboard. You have to remember this board launched with the launch of Threadripper Pro 7000 series. We are in the 9000 series, and the jump from Zen 4 to Zen 5 was really significant, just to catch you up to now. If you're doing scientific compute workloads or workloads that depend on AVX 512, even user interactive workloads will feel a fair bit faster. Now, the good news is that you can also get Zen 4 pretty inexpensively. So for this build, I'm going to use a second-hand 32-core 7000 series Threadripper Pro. Threadripper Pro gives us access to 8 memory channels. The WRX90 motherboards will only work with Threadripper Pro CPUs. TRX50 motherboards, on the other hand, will work with a Pro or a non-Pro CPU, but the TRX50 motherboards, by and large, only have 4 memory channels. It doesn't make sense to try to use a Pro CPU in a TRX50. There is one exception to that, which is the Gigabyte AI Top. We did a video on that. It's the most returned motherboard for Threadripper that exists, but that's because it's misunderstood, not because it's crappy. But if you're interested in that, you can check out that video. But this is true. This is true, a truly luxury motherboard. 7 X16 slots, 18 plus 3 power phases. It has 5 little fans to keep the VRM cool that you mostly only need when you're overclocking. It has ample rear I/O with dual 10 gig LAN. A couple different revisions of this motherboard have had different implementations. This one is the dual Intel 10 gig E, and that is the X710 chipset. I also love that this motherboard has dual MCIO and dual Slim SAS, so you can use external peripherals, things like U.2. When we do this kind of a build, I find it's easier to just go ahead and mount the memory and CPU in it. And if you're using a tower cooler, you can go ahead and mount the cooling. We will be using an AIO, which I will talk about more in a second. This is the Fractal Meshify XL. We reviewed this separately. This is what I'm going to use for this build. Why? A couple of reasons. One, it's got a lot of airflow. The fans that Fractal comes with are, they're good, but better fans for more airflow are always welcome, especially with a high-end build like this. The airflow over the DIMMs is going to be the most important, and we may need a 3D printed accessory to help us cool the memory. That said, I don't see any reason to remove these fans. We can just add more fans along the top and the rear if we need to, or a special memory fan or something like that. There's also room to mount fans on the side here, so you can have a lot of airflow for the Meshify XL. It's also designed to sort of scoop air from the front here, or you can put in a custom loop and do custom loop cooling. For the cooling, I'm going to use the Silverstone AIO, the XE360. This is the top of the line premium. These are used in server deployments that have a 5-year lifetime AIO cooler. If you have problems with these or gunk or any kind of failure, let me know, because Silverstone has staked their reputation on this cooler. I've personally deployed a lot of these for one-off systems and specialty systems and that sort of thing. Falcon Northwest uses this with their build, so if you've seen our high-end videos on high-end builds, if you don't want to DIY it, Falcon Northwest uses that, and so that the fact that it's like, oh yes, I've compared notes and we have come to similar conclusions. Good job, Silverstone. For this particular build, we will be using the ASRock 1600 watt power supply that has thermal temperature tripping sensors in the 12V2 power connectors. I'm going to be running $8,500 GPUs. I want early warnings at the first sign of trouble if maybe I haven't gotten the connector in all the way, or if there's some problem with the connector. I want to see that. I want to know about that ahead of time. And so ASRock has built temperature sensors into the connector to know if the connector is overheating on their 1600 watt power supply. This is also the only power supply that you can get that will work on a standard 15 amp North American breaker to actually power two 600 watt GPUs and a 350 watt CPU. So let's get this thing put together. Power supply, motherboard, and our cooling. And then we'll talk about some different GPU options and how that works out. These also use the 12V2 power connector, by the way, but these use much less wattage, and so because it's much lower wattage, much less danger of, meltage. Storage, and what your storage options are, even beyond M.2, and all that sort of thing. But for now, Meshify XL, and a ridiculous, I would not use any power, even if you're only going to use a single GPU, 1200 watts and on up. It's probably worth spending the extra $50 to $100 to get the 1600 watt power supply, just in case you you never know what your career is going to take you. Oh, I would give you one word of caution if you are thinking about buying a pro GPU, like an RTX Pro 6000. There's a lot of graybeards out there that are very confidently incorrect. It's like, I purchased P&Y RTX Pro 6000s. And the reason that I did that is because this is not the first time that I've been to this rodeo with NVIDIA. I'm working on another video, which is Blackwell, everything that's gone wrong up until now. But in a nutshell, one of the things that went wrong with my Blackwell Pro 6000s is they shipped with a beta VBIOS. There were 1,000 cards in the first shipment that shipped with an incorrect VBIOS version or an older VBIOS version, and NVIDIA will not give you the VBIOS upgrade directly. And in fact, here is a thread on NVIDIA's own forums where an NVIDIA rep is telling someone that bought an RTX Pro 6000 from Newegg that they're going to have to go back to their reseller to get a VBIOS, which Newegg is completely unequipped to do. P&Y is equipped to do that, and so if you open a ticket with P&Y, it might take a little bit of finagling and a little bit of back and forth, but they will send you an updated VBIOS file. This is something structurally idiotic that NVIDIA has created with their resellers in terms of card updates, but I've been through that before. It's been this way since third generation cards, and so unless you buy through a verifiable supply chain and you supply the documentation to them, you are not going to get updates for your card, which is insane, but that's just the reality that we live in. Now, we are at the next stage of our build. I've got the motherboard mounted. This is our WRX90 from ASRock. Yes, it does have 5 little fans, but the little fans don't kick on unless you don't have sufficient airflow in your system, or the system is really heavily loaded, or you're overclocking your CPU. So mostly you don't hear those. You can pretend they're not there. This is the Meshify 3 XL. This is the smallest large case that makes sense for these Threadripper Pro motherboards. They're oversized. And even when you mount it in this case, you're gonna have to take some stuff out. The cable cover, and then there's this plastic cover for a vertical heatsink thing on the side. Oh, and by the way, did I say 32 core Threadripper 7000 series? I meant 96 core, the 9995 WX. Are you gonna put this system up against the Talon 96 cores? Dueling 96 core systems? If you just wanna buy a system that is ready-made, you should check out the Falcon Northwest Talon system. I've got one, and we did a video on that, and that thing runs amazing. But if you're building it, I'm here to hold your hand and walk you through the build and tell you the important stuff. Now, for this motherboard, it does require an extra power connector at the front edge of the motherboard. There's 2. There's a right angle one that'll clear GPUs, and then there's one that goes directly into the motherboard. You do need both if you're gonna run more than 4 GPUs, but I found with 2 to 3 GPUs, the one connector is fine. You'll actually have a red light on the motherboard if it doesn't have sufficient power. The consequences of not plugging that in are that your PCIe devices don't get any 12 volt power. They don't initialize, you're not gonna get any video out. You do also have extra 6-pin PCIe style power connectors at the top edge of the motherboard. That is for overclocking. You mostly don't need those. You will need both 8-pin CPU power connectors at the top edge of the motherboard to power the CPU and the rest of everything else. But ASRock does not connect the 12 volt lines for the main ATX 24 pin connector to PCIe power because they have so many PCIe lanes. All of these are 16 lanes except for the one next to the bottom, which is 8 lanes. The other thing that you have to keep an eye out for is memory throttling. It's pretty easy to check this with MLC. There's a script on the Level 1 forum. MLC is Intel's memory latency checker, but it can also check bandwidth, and you can run that in Linux or Windows. And you run that a bunch of times in a row to find out if your memory is throttling. You can also use Hardware Info 64 to monitor the temperature of your DDR5 DIMMs. It depends on the kit of memory, but generally if the memory part is above 75 to 80 degrees C, it will start to throttle, and then the system will actually shut down completely if you get much beyond that. Depends on the kit of memory. Some kits of memory throttle sooner, some throttle later. The particular kit in here I have is the brand new G.Skill 512 gig kit. I'm doing a separate review of it and some talk about DDR5 memory. I did another talk a while ago about heat spreaders versus not heat spreaders, and I may have been a little bit wrong about that. With heat spreaders makes sense if you have pretty good passive cooling, but if you have active cooling, then not having heat spreaders is a little bit better because there's more room for air to get in between the DIMMs. But if you have heat spreaders, the heat spreaders will even out the heat going across the DIMMs, and so you can have some dissipation if there's air blowing over top of it. But this is a 3D printable bracket for 40mm Arctic fans, and so you can add this to your build, and this will run really well. This will, to keep your memory cool. In this build, with the G.Skill memory, with the side on, it was not necessary, just barely. The DIMMs had the hottest hot spot of about 85C, and know that the voltage regulation part of the DIMM can actually run hotter than the rest. A lot of the time the voltage regulation part is rated for like 100, 110, 115 degrees C, but the actual memory chips themselves are not rated for that level of temperature. It's just the voltage regulation part on a DDR5 DIMM. So the memory temperature is something you need to keep an eye on because your best worst case scenario is the system is just running slower than it should. Your worst case scenario is you will see memory errors from the memory running that hot. Well, now hang on there a second, Wendell. It turns out that the 32-core Threadripper Pro is still not fast enough to really saturate the memory, so the memory will run hotter when you're using a beyond 32-core Threadripper Pro CPU, which is really interesting. So the 96-core, the 9995 WX in here, even with the G.Skill kit of memory, I think you would be best off having cooling. The other thing that I've learned is OCCT for memory burn-in testing is an even worse stressor than MLC, Intel's memory latency checker. So this in the CPU plus RAM test, if it can run for an hour without thermal runaway or without introducing WHEA errors, that is fantastic. That is solid. That's what you should be testing. But we'll talk more about that toward the end of the video. But 32 cores is not enough to really stress your memory, it turns out, in Threadripper Pro. I have added an Intel Optane P5800. These are cool. These are very low latency. I don't really like, unless you have a really niche use case, PCIe Gen 5 SSDs generally for most use cases have caught up, but these are really low latency, so if you work with a lot of really tiny files, you need really low latency IO storage, it can still be worth it to try to pick up a P5800 on like the used or secondary markets in order to be able to run things really absurdly fast. The latency on this PCIe Gen 4 device is about half even a PCIe Gen 5 device, which is, Optane has a lot of really, that's a whole other conversation. But U.2 storage is pretty easy to get your hands on, and new or old, it can make sense. Another option, this is a Kioxia CM7. This is an E3 CM7 and a PCIe Gen 5 breakout card. So this is 4 Gen 5 lanes, and I can use this in our X8 slot at the bottom, and then boom, now I've got 16 terabytes of flash via our CM7. And if I were putting a 9995 WX system together with a couple of RTX Pro 6000s, then all of a sudden I've got myself a very, very nice AI workstation. I've put this together, and all in, yeah, it's gonna be on the order of like $50,000 for an AI workstation, but it's gonna be as fast as something off the shelf that is like $75,000, $80,000 when we're talking about a server, and this is also going to be much more quiet. When you're comparing the price of AI servers to AI workstations, even in like the Falcon Northwest pre-built scenario where you can order it with a couple of high-end AI GPUs, you're going to get a better deal on that even through Falcon than you would on something that is rack mount and serverish, at least for, you know, in the neighborhood of 2 high performance GPUs. It's definitely something to think about. Now, of course, for E3 storage, it just lives on the PCIe card. It screws in just like anything else. If you wanted to do a custom loop, you could do it. There's mounting stuff in the bottom of this case for, you know, a reservoir and all that kind of stuff, but I found it easier to just go with Silverstone's XE360 AIO. This 360 AIO can deal with all of the power dissipation requirements. That XE360 can be a little loud at the default fan speeds on this motherboard. You are gonna wanna tune your fan speeds with this platform. You could also do a push-pull configuration, and that will operate a little more quietly. I think you can handle it from here. This has been a quick look at the ASRock WRX90 in 2025 and some of the updates that it's had, and using that as a platform, as a chariot to carry our Threadripper Pro CPUs. Now, as a preview for what's coming in our G-Skill video, the core count does actually make a difference in memory bandwidth. So from that 32 core Threadripper Pro CPU to the 96 core Threadripper CPU, all things being equal, you can get another 100 gigabytes per second of memory bandwidth. But if you're interested in that and interested in the performance implications, you're gonna have to stay tuned for that video. I'm Wendell, this is Level 1. This has been a quick WRX90 Threadripper Pro build, quick sort of DIY how-to, and me telling you, yes, you can do this, you can build this. It is a little bit paint by numbers and the parts are wildly expensive, but if you have a computational need to do this and get it done, you can do it, and we'll help. You know, hit me up on the forum. I'm Wendell, this is Level 1. If you have any questions or I missed anything, or you wanna try a particular workload, hit me up in the forum. I'm signing out, and I'll see you there.